Start recording. There we go. Okay. Plus O2. What are our products of combustion? Yes?
CO2 and water.
CO2 and water. Yes? So all of the carbon becomes part of CO2. All of the hydrogen becomes part of H2O. So that's what that says here, is that all the carbon is converted to CO2. And these little combustion analysis devices, there's a chamber for the burning, and then the products pass out into another chamber that has like a carbon dioxide absorber. So it absorbs the carbon dioxide so you can collect it and measure its mass. Yes? So we collect the carbon dioxide and we measure its mass. Next, there is a water absorber. Okay, don't ask me what the actual things are that do this absorbing. They just are, okay? So the hydrogen is all converted to water, and then we collect the water and we measure its mass. Now, do you remember our little poem for how to find a empirical formula? Find the mass. And what are we finding the mass of? Each element. If we know the mass of CO2, could we find the mass of carbon? We sure could. There's a few ways we could do it. Okay. If we know the mass of H2O, could we find the mass of hydrogen?
Yeah.
Yes, we sure could. And again, like I said, there's a few ways to do that, but which we'll look at in a moment. But then we can find the moles, and then we can divide by the smallest and times to a whole. Yes? So the only thing that is different about this from what we did last day and the day before a little bit is just that we now have to deal with CO2 and H2O. Okay? So let's just take a look at how this would be in a real example. We have methane, and you can see that that one carbon from methane transfers over here, and we still just have one carbon. Yeah? We have 1, 2, 3, 4 hydrogens. And over here we have 1, 2, 3, 4 hydrogens. So this is just to illustrate that all of the hydrogen has become part of water and all of the carbon has become part of carbon dioxide. So how we find the mass of each element, this is the only new bit. This is my preferred method, and you'll find out why in a moment. Okay, there are many ways to do this, but you remember last day we started looking at the mass ratio. Okay, it's a very simple way to get to our mass of carbon. Yes? So if I had X grams of CO2, then I would have times 12 grams of CO2 for every 44 grams of carbon for every 44 grams of CO2. Is that ringing bells? Because, of course, carbon dioxide is 1 carbon and 2 oxygens. So we have 12.0. 2 oxygen is 32.0. So the mass of the entire thing is 44 grams. And so 12 of those 44 grams are carbon. So there's 12 grams of carbon for every 44 grams of CO2. Yes? Okay. So we would do that and we would find our grams of carbon. Do the same thing with water, except for you would use, there's 2 grams of hydrogen in every 18 grams of water. Now, other ways to find the moles of carbon, because from here you can then find your moles of carbon and you can find your moles of hydrogen. So this is method 1. Method 2, we want to find moles of carbon. We could take our grams of CO2, we could convert it into, what can we normally convert grams into? Moles. We could find moles of CO2, and what could we find for moles of CO2?
Liters.
We are looking for moles of each element. So we can find the moles of C. Okay? We could take our grams of H2O, and we could find our moles of H2O, which would then allow us to find our moles of H. Either way is fine. I don't care what you do. Yes? The only reason I like to do it this way, method 1, is because sometimes we have a third element. Yes? So let's say our sample contained carbon, hydrogen, and nitrogen. Yes? And let's say that our sample of this compound had a mass of, I don't know, let's just say 10 grams. Okay, so I had 10 grams of that. If I use method 1, I might find that I have 3 grams of carbon and 5 grams of hydrogen. Yes? Right? Because I'm finding my grams of carbon and grams of hydrogen. Could I then find the grams of nitrogen in my sample? Yes, I would do. So what would the grams of nitrogen equal? 10 minus 5 minus 3 is 2 grams, which is why I like this method, because you actually have the grams of each element. Whereas here, you would say, oh, I've got moles of carbon. You would then have to find grams of carbon before you can do that subtraction to find the mass of your third element. Yes? But it's not, it's like, you can do it. It's not a problem. Okay, so whatever makes the most sense to you. So this is just summarizing what we were just talking about. If you have a third element, X, and this might be oxygen, it could be nitrogen, it could be bromine, it could be chlorine, it could be who knows what. So the mass of that element will be equal to the mass of the sample of the compound. Not the molar mass, but the mass of the compound. That's why it says sample. Minus the mass of the carbon and hydrogen. Sometimes people like to think that oxygen, oh hey, oxygen's in carbon dioxide, oxygen's in water. Couldn't I calculate the amount of oxygen from the carbon dioxide and the water? But there's a problem with this. And the problem is that the oxygen that I want to find this one, and I want to find this one. Yes, I want to know that there's like 2 moles of oxygen or whatever. Yes? But over on the right-hand side, how many oxygens do I have in my carbon dioxide? I got 4 oxygens. I only wanted to find these 2, but I've got all of these other oxygen from the air. And they also become a part of the carbon dioxide and the water. So you cannot say, I know how much oxygen was in my compound because from the CO2 and the H2O, because some of the oxygen in those compounds came from the air. Yes? So just treat oxygen like any other nitrogen or bromine or chlorine or whatever else that you wouldn't be tempted to do that for, and just do the subtraction. Okay? Mass of the sample minus carbon minus hydrogen, and then you get whatever's left over. You look pained. We'll do an example and it'll get better. Okay? What's happening? It's Friday afternoon. This is way too much. Okay, I understand. So you cannot do this. You cannot say, I have my grams of CO2 and I want to find my oxygen. I have my grams of H2O and I want to find my oxygen, because you'll end up with more oxygen than is in your compound. Okay. So let's do an example to make this a little bit better to understand. We have isopropyl alcohol. It is composed of carbon and hydrogen and oxygen. We combust 0.255 grams of isopropyl alcohol. So our sample is 0.255 grams. And we have 0.561 grams of CO2 and 0.306 grams of H2O. That's my summary information. Would you guys be able to find the masses of carbon and hydrogen from our grams of CO2 and our grams of H2O? Would you like to try that? Okay. So we're going to find carbon and hydrogen. We'll find carbon from the CO2 and we'll find hydrogen from the H2O. Once you have found carbon and hydrogen, then you can find oxygen by subtraction. Okay, so give that a go. Okay. Okay, so probably if you have what's the answer? I'm not sure. I don't think I'm
I'll take stuff. Yeah, but no, you don't. With no, it is a diatomic, but It's part of the compound. I don't know if you're finding. No, yeah. It's not. But you still find two. No, do I think they're each two? Yeah, that's part of the formula. No. You're finding two H's. No. Oh, no, it doesn't matter.
So the key thing here for this unit is.
Wait, is that it?
Take the
Round. And more mass. All I need to do is convert the bottom.
Do I really have to write all that?
So if I am given, what is the density of methane? Right?
Why did we do that?
I really hope I'm not that.
So I thought we were. So that's backwards. Density.
Okay, so, wait, but what are we trying to find? Oh, what's the math? Yeah, I did. 0.06.
Wait, what if we?
Oh, what if we're doing wrong?
Yeah, this is.
We didn't learn it yet. Yeah, but then you do from here, you do 0.15. For the answer keys, it's a completely different question.
For this example?
No.
Oh, for the-
six,
yeah.
answer key was wrong.
Yeah, the answer key is just a completely different question. I'm like, oh my God, what is wrong with me?
I was like, am I looking at the right section?
No, I don't know what happened. Like, I've got, and I'm looking at,
These are more confusing.
what's that?
These ones are more confusing. The ones like these, so it's very easy to get confused.
Like, these two are the same, right?
Yeah, they're all like.
Wait, so are they? Yeah.
Okay, so if you want to check your masses, you should get 0.153 grams of carbon. You should get 0.034 grams of hydrogen, and you should get 0.068 grams of oxygen. Is that what you got?
Yes.
No?
Yes.
Okay. If it wasn't, you should take your 0.561 grams of carbon dioxide, and there are 12 grams of carbon in every 44 grams of carbon dioxide. And you get that? Did you get that one? Let's see. let's see. Okay, so this, yes. No. Okay, so we're not finding oxygen in CO2. We want the oxygen in the isopropyl alcohol. Yeah? So you're gonna say my isopropyl alcohol is 2.255 grams.
Oh.
Of that 2.255 grams, 0.153 is carbon, 0.034 is hydrogen, how much is oxygen? So we take the mass of our sample. Yes? Does that make sense? Now, I want to point something out to you here. At this point, what should we be doing next? Mass to moles. I will say that there were at least a few people in block 2 who were tempted to divide by the smallest right here. Yes? You can't do it. You might end up with numbers that look pretty good. If you divide all of these masses by 0.034, you'll get like 4.5, 1, and 2, and you might be like, hey, those look pretty good numbers. But it's wrong. Because what will happen is you'll end up with the formula C9H2O4, which is not the correct answer. And if you tried to draw a structure that contained 9 carbons, 2 hydrogens, and 4 oxygens, you will not succeed very well because we need hydrogens to like fill in all the gaps on the on the carbons. Yeah? So just be aware you cannot just divide by the smallest mass. You have to convert to moles first. Okay?
Wait, let me try it. No, that's just.
And then I was thinking it would just be nice for the rest of the block for you to just be able to work on things.
Divide by.
Yes.
Small. So it's 0. Okay. I'm just seeing if you're right.
For sure.
Thank you.
Oh.
Is that a perfect number?
Wait.
But that's okay because I made them up. Yeah.
Was it intentional?
For them to be perfect?
Yeah.
Yeah. Well, you should get nice numbers.
Wait, so it's CHO.
C3.
Oh, C3H8O, right? Empirical.
Okay.
Okie dokie. And you guys can then try some of the questions on page 129. Or you can work on the practice quiz or whatever. Yes? I would say maybe give numbers 1 and 3 at least a try. And then there's some, are there molecular formulas? Number 7 has a molecular formula.
Yes, please.
Yeah.
Why is it the last page?
Why is it the last page? Because we're into our next unit, reactions. You're like, I just thought we would do them all from now till the end of time. But we... But it's okay, because we will still do them all from now till the end of time. You never get away from the mole.
Lovely. Okay, let's try number 1.
I could have stuffed animal more. Get myself a stuffed animal.
Oh, that would be cute.
Right? I have a moose.
Where? Oh. I didn't know.
I have a moose and a dog.
Hydrocarbon is burned together. CO2 and air empirical formula. Wait, what do we do for this?
I had a student one year who had to like have his emotional support animal. For his test. No.
Girly.
Probably should take
Oh, I mean, you do.
She's here as a hospital.
I mean, we just we didn't actually need it, but those like those Saturdays, you know.
No, it's different.
Yes.
Like 20
Oh,
shoot.
Just like we did it like in
That would be 44. On the test what? Oh. So you calculate the mole, right? Right, Dorothy?
Yeah.
Ah. Stop. You're confusing Dorothy.
So this isopropyl alcohol is made out of carbon and hydrogen and oxygen.
You get 60.
Isopropyl alcohol is estimated by 5 grams. Of that amount, 1/3 is carbon, 3/4 is hydrogen, that are left over. It's oxygen, so carbon in there. Yeah, those are like, that's gonna include some of the oxygen from the air. Yeah, she was on that. Okay, yeah. Sure thing.
Wait, what are you trying to find?
Good. It is.
Hydrogen, right?
Oh, we're gonna divide by the smallest one. And the smallest one is this one. Oops, but that's okay, because you kind of ended up like multiply, yeah, but yeah, divide by the smallest one. It's still correct, that you would have lost.
Why do you not have an eraser?
I lost it. How do you think it's supposed to represent things so that it's good? I was like, I don't know my wrong side of trying it. But everyone's like, so why did you? It's like, okay, if you think that you're right, and everyone's like, there's like, you're all over.
I got negative 0.09.
What do you mean?
Me
Wait,
too.
This is basically do more than 4
Miss Ben. Wait, what did we do wrong?
I'm looking.
Yeah, so.
No, we did everything right though. Let's see, one person.
By mass.
Oxygen is
Oh,
not.
there's-
What do you mean oxygen's not included?
Oxygen wasn't included in the song. So we find it.
No, but like, the thing is, you
Let me-
won't be some vacuum. You take like a bunch of first get or like you tell yourself.
Oh, right.
It's like,
Yeah.
you have one it's gonna be like.
You're like, that's way easier than that.
So you do a little-
That's the black horse.
Yeah. You're finding a little I know my.
It's not easy to file.
No, that would still give us
Catering,
negative
we
either way.
He used to take biology and physics and chemistry.
Obviously. Do that now.
He's learning how to cook animals, biology.
Bro,
And probably clean
I wouldn't say I did pretty bad, but it's not bad.
like how bad.
Not bad.
Hi, we both need help.
Okay,
It's on the first question.
okay,
I'm done.
Oh.
Because like when we subtract
okay.
These elements are kind of biology. Yes, in biology, there's also.
Part of your compound.
why are we finding oxygen
And
when
you
you need
never do anything other with this number other than 5 grams of carbon. Never do anything with the CO2 other than 5 grams of carbon. Never do anything stage 0 other than 5 grams of hydrogen.
So then after we find the 2 grams, we just go straight to there.
Yeah, and if you needed to find oxygen, you would take the mass of the sample and you would subtract the mass of the carbon and the mass of the hydrogen.
Exactly.
Not, but here, if you try and do that, you'll end up with like a negative number because.
Yeah, we got
like,
negative
yeah.
0.09 and we were like, what? I'm like, there's a negative, there could be a negative in chemistry. It's fine, okay. So now we find the empirical.
Okay. I gotta do this one.
That's fine, that's one.
There are. Everyone, we've been asked what our test looks like. There are 18 multiple choice questions. There are 5 written response questions. 18 multiple choice questions will not require like hard calculations for the most part. They'll be easy calculations, but they will require you to actually understand things. Relationships between particles, like atoms and molecules, like volumes of gas at the same temperature and pressure. Like you'll need to have a conceptual understanding for the math to be easy. Okay? No, you're not gonna have a practice.
Wait,
Everything. Everything. Yep. And if, I gave advice to the other block, so I might as well give the same advice to you guys. My advice is that this is, for some of you, going to be your first like senior or one of your first senior exams. For some of you, it'll be like not your first, but they are harder than like grade 10 and stuff like that. So you want to pace yourself accordingly. A lot of people get to this course and they're like, oh, I want to take my time with each question and make sure I get the right answer. Don't do that till the very end. Okay? The first time you go through that test, go as fast as you can. Yes? So you're going to look at the first question, you're going to go, oh, I know the answer to that one. Bam. Yes. You're going to look at the second question and go, skip it. Number 3, moving on. Okay? Right? So you're going to just skip any question that gives you pause or that's like, oh my God, this is going to take 7 steps to do this. I know how to do it, but it's going to require a lot of math. I'm going to come back to it later when I have the time. Okay? But go and get as many marks as you can at the start. That way at the end, you're not like desperately like, oh, I spent all my time on multiple choice number 5 because it was hard. And now I don't have time to finish the written response, which are worth more than 1 mark, right? So you have to manage your time, manage your resources. Remember, you get scaled. So if you miss a question, big woo, right? Not the end of the earth. Right? You want to go and you want to hit all the questions where you know for sure what you're going to get. Yeah? On my other physics midterm, not that one where I got 48%. This was with my other teacher. It was a physics final. And there were 8 questions, all written response.
And I looked at the first one and I was like, capacitors. I do not understand capacitors. Never did understand them. Never did, ever. I was like, oh. Question number 2, I was like, Question 3, 4, 5, 6, 7. Oh, I know how to do 8. So I did question 8. My brain calmed down, right? I was like, I'm in the groove now. I can do question 8. And then I kind of went back and did everything else. I never did do question 1 because I still do not know how to do capacitors, right? But I ended up getting like, oh, it was my best physics mark. I got an A- in that course, which was astonishing because me and physics, right? But the teacher was also a really good teacher. Like he was very good at his job. So yeah.
This is not my thing.
Yeah, physics was not my thing either, but I think he didn't teach us all of the curriculums. He said, I do not believe in the fire hose method of teaching, which is where, you know, the students open wide and you aim the fire hose and whatever goes in, whatever doesn't, and you're just lucky at the end if you got something out of it, right? He didn't believe in that, so he taught us like really well. Like I could derive formulas using calculus. I don't remember anything about calculus, but it was exciting. I was like, so yeah. So don't worry if you don't know how to do question 1. It's all right. Just move to question 2. Just remember, Ms. Spence took her all the way to question 8, the very last question before she found one that she could do. Yes. There were only 8 questions. Yeah. So, right? Yeah. Yeah.
I wore this one. So I got like 1.49.
Uh-huh.
Then
That
like
1.5.
so like on the test, I guess like what would be like
I usually like writing about like 2 or 3.
and then
And then I'm like, oh yeah, that's really close.
and then you just round the 100 to 10.
Yeah.
And then you multiply by 2. Yeah. Okay.
Yeah.
Okay.
Well, except for if you got like a 3-3, right? Because you're not going to run a 3-3 to a 3, right? Because if you've got 0.33, then that's a third,
Oh, 0.33.
right? Or if you got a 0.67, then you'll multiply by, right? So you got to look at the 2 decimal places, right?
Wait, so if it's 0.3, multiply by
Not if it's 0.3. If it's 0.3, you've done something wrong, probably.
right.
If it's 0.33, you're good to go. Okay?
0.33.
Yeah.
Oh,
I mean, you might have 0.329, you might have 0.332, right?
No, let's see. Yeah. First time.
not even.
I mean, we did it all last year.
I'm
Right?
gonna memorize
So
it.
that's 44.5. One of those solutions already, right? So we're just gonna hit on the math portion of that and a couple of things. And that's mentioned, so probably like reactions. One test. So you get 6 and 7.
What?
And then you get 8 more or something. Oh, I forgot about stoichiometry. It's just like doing the whole sounds like to the compounds in a chemical reaction. It's not more issues. And then after that, we get the atom get bonding.
What? Oh. Try your best. You're like, what am I supposed to do?
Yeah. Yeah. And we may all do them all.
Amy, I felt you.
Like, I ran up.
See, you hear her? She's like, wait, what am I doing?
And I taught math. And we figured out. Or.
So you're trying to find VR.
So we'll see. Yeah, that's what's happening, great.
It's always surprising.
Total. So what she says, find the
Why do you find this one?
amount of carbon and it's
Well, we always take across all of it.
Yeah.
Because that way, if we split up the differently, you're not gonna progress with that. Right, so you find what I'm finding. That's not a problem there, it's just. No, I just always, I always do myself when I think, I still want myself like, oh, I gotta get, you know.
No.
Five? Really?
You have to. And that's on. On Delvin's.
What? No one wants right now.
Oh,
no. It's
It's a problem.
Yeah.
Delvin's soul's kind of.
Probably the imperfect
So like,
On purpose.
Okay, so we take out the values of.
when I think it's like, I was gonna read you, but.
Yeah. There's almost industrial.
This number for mass.
See?
Just
Study everything.
So like,
And then you make that.
No, that's not how it works.
what?
right?
Because that means.
Um,
I was doing that. I use one of the four.
What are the four methods?
Either you find the person, you find the way to look at the way to find the person, or you find it here.
oh, I said, well, I wanted to be a research scientist. And then I was like, did research science.
Just come up with like, you just gotta think like that. What's VR? Let me find quite the way.
Yeah, I was like, you know, cause like, you're doing labs, and I enjoy doing labs. It was like all day. Right, and then you do something, and then there's more. Right, that's how it works. A lot of the time with science, you're like trying things. You're trying, oh, it didn't work. Trying, oh, it didn't work. If everything worked like after like, you know, a month, science would be super easy. We wouldn't have to wait, we wouldn't have to wait for people to develop that COVID vaccine. We were like, oh, here it is. 2 weeks later. Oh, 6 months later, we're done.
Because it's hydroponic.
I was like, I don't know. And then, so I was like,
Actually, I did that. I need to try to think you probably.
You think it'd be a good idea
You gotta know yourself.
to write one.
Or I don't know, go with something.
I remember so small, but it was one.
Yeah.
That's
That's
very sad.
I'm gonna.
they were reading it and they had no expression before they. Right? I love it.
Yeah, and I'm actually.
You have to use like the overhead slides that are drawn by hand, right? Slides that draw what happens. Together, and then I just see bacteria doing this thing.
Yeah.
And then,
I'm done.
whatever.
Good day. You don't need 2 questions. One whole paper.
Bro, my Instagram for you page is filled with chemistry.
In one direction.
Chemistry? Like there was this.
No, with chemistry. I love chemistry. I love chemistry. Because I love it more than pre-cal. Math and I are not bonding. We never bonded together. People are like, we're Asian. You should get this. Sure, bitch. Doesn't mean I would like math.
And it
Like, I like, Mom, I don't want to go for the early. Can you kidnap me? No. What?
Actually, yes, I was like this.
I don't want to go to early. Shut up. No, I was excited and now I'm not. I'm too lazy.
Oh my god. I'm like, I feel lazy.
I think because like that's also like there's considered like it's a license thing, like you get licensed by because it's being licensed inside,
My
right?
favorite program.
So it's like serious and like
So you know what you want feedback from my peers because they were like, that was.
I took it. I usually take it with Dylan. You
It was not so much.
but
It was like, I thought you
I already took it.
Sure. It's like,
And now I just took it by myself. And my friends came up. I'm making friends.
so I was like,
They're all in university. Because they want money.
Yeah.
For uni, being very expensive. One girl was
You have no.
and then the other one is in UK right now. England. She's studying.
You know.
Oh, she's in med school.
Yeah.
I was sitting in between and they were talking about uni and I was like, one's EBC engineering, one's London med school, and I'm like, get out of here. Like, get out of here. Because the London med school, she graduated last year. And apparently London's med school is shorter than Canadian med school. So she went to Oxford. London is in English anyway, so she was fine. London was lunch radio. And then the other guy, he's like, oh, second year.
My first year. Survive. First year.
Yeah. So, yeah. That's because
I know lots of people.
yeah, but apparently she survived.
Really did.
No. I'm like, oh yeah.
Yeah, right? You're allowed to time.
One is skin beer.
Very like that's fine.
I guess we have to say in that things like that.
That was good for me. I was like, mine is a plan. I need to know. That's from my mind. Of course, that's like. I don't know.
Like, they don't like, oh yeah, so we can. I thought you know, like, oh, you should ask them for their coffee.
See ya.
Wait, is it?
No, London has a UK one.
Really?
Graduated last year.
Oh, she's still on? Oh, she
She graduated high school last year. So then during summer break, she finished course. And then
Hi.
How big is this chapter like compared to other chapters?
Similar?
Similar?
Yeah, but we won't be doing all that like extra like here's a solvent and here's a solute and all these other things, right? Like we spent a lot of this unit like going on tangents everywhere else. Yeah. Next unit will be like, okay, reactions. Boom, 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 done. Yeah.
All right.
Okay? It's a huge course. I know. Just breathe. You will be fine. Okay? Yeah.
But at least like the taxes like important in schools.
so like